Okay. Commencing with solving proportions. And so we begin. Solve each proportion, leaving your answer as a fraction in its simplest form. So, what is the value of p in this case? Well, isn't p supposed to be 1/3 of 4? So I'll try this. Not sure if it's true. And here, k should be 1, but we'll check. Okay, so they want it in the form of a rational number, not in a sort of as a decimal. That's totally fine. There. Okay. So we could just say, what, 32/7 then? And here, 20/3. Would that be fine? Let's check. And that's all good. Okay. 35/2. Multiply on there by 5. 35/4. And here, flip both sides to get 6/7, then times across. So 30/7. Flip both sides to get 5/6. 5/6 equals 5n/2. So 10/6 equals 5n. So 10/30 equals n. So 1/3. And we check. Correct. Solve each proportion, rounding your answer to the nearest hundredth. Okay, so 2.3 times 3.6. What's that? 8.28. Over 7.7. But here they don't want it in this form. All right. To the nearest hundredth. So I guess you use a calculator then. Oh no. Are you kidding me? I just bought this. All right. Oh, there's life in it. Okay. .08. Here. .34. here. $22.89 here. $12.06 and check. Okay, so I disagree with how they've rounded, but overall correct. And check. Correct, good. Next. And check. And nearly, but fix. Oh, I see the mistake. There, I forgot to multiply. 7x at 42 equals 10x, so 3x equals 42, so x is 14. Negative 27. Three. check. No, that's not right there. Fix it. Oh, I see. No, not at all. Mm. And similar polygons, or so it appears. Yes, that's next. Okay, so 18 to do. 18 to do. State if the polygons are similar. To go from the top to the bottom. Oh no! No, 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 no. Lapsing in concentration. Try harder and better. Here. Seemingly, but this angle down here, by being a consecutive interior angle of a parallelogram, would be 50 degrees. And angles are preserved under scaling. Here. No. 24/20 is not the same thing as, is not equivalent to 48/40. The left is, or perhaps it is, and I'm just being dull of mind again. 6/5, so it is indeed. I'm just being slow. So I should say yes. Yes. 24/20 equals 48/40. Indeed, K, to go from the larger to the smaller, is 5/6. Okay. How about here? Well, the angles are preserved, but to go from 8 to 10, you have to multiply by 1.25. To go from 14 to 21, sorry, it's not the same. And here, well, to go from 20 to 25, you have to multiply by 1.25. And that works out here just fine. But what about here? To go from 12.4 to 15.5? Well, a quarter of 12.4 is 3.1, and so that's indeed true. Angles are preserved and sides are appropriately scaled. And we see that that's all correct. Good. What about here? Well, you have to rotate it first. Now, okay, so the angles are preserved, essentially. And to go from 5 to 16, multiply by 3 1/5. Okay, does that work out for 6? No, it does not. So we say no. How about here? Well, to notice we have 32 and 36, and they are in the ratio of 8 to 9. But here we have 7 to 8, so no. Okay, angles match up. And 40 and 29? No, they're not similar. That's in fact in a ratio of 4 to 3, but 40 to 29 is close. And here, well, 18 to 21, reduce that, and we get 6 to 7. And over here, 6 to 7. So yes. And what's the scaling factor? To go from 18 to 30, divide by 3 and multiply by 5. So there you go. The polygons in each pair are similar. Find the scale factor of the smaller figure to the larger figure. Oh, so you multiply by 2.5. Or 5 over 2. Multiply by 3 over 2. Or 1.5. Multiply by 5. Multiply by 6 over 5. And check these four. I see. So they're doing it as ratios. Like it's a ratio of 2 to 5. The scale factor, that's how they call it. That's fine by me. 2 to 5. We could say that's on us 2 to 3, smaller to larger. 1 to 5. 5 to 6. All good. 2 to 3. And here. Okay, 3 to 5. And here. 1 to 3. And here. No, that's not quite right, is it? So what's going on? Is there like a missing side or what? One to 2? What do you mean? I guess I don't get it. Now I'm going to use some of the polygons. The polygons in each pair are similar, so find the missing side length. Okay. That would be 16. Here. Okay, 20. And check. Oh no! What do you mean by this? So we're just supposed to go by eye? Years of training has taught me not to rely on them. Okay. No. Foolish. No. Of course. Good. Okay, 10. Hmm. And 7. And 8. And 12. And 7. And 7? Is that right? It is right. Okay, that's great. Oh, I'm loving this. Okay. Are they similar? No, they are not. I don't believe they are. Because these would have to be vertically opposite. And so they would have to be congruent, and they are. But anyhow, can't you see that du and ue are both 16, whereas in this case, so they're both, I mean, they're just simply not. But anyway, probably here they will be. Scale triangle FGH by 6, then it's congruent by SSS. So I mean, they are. But now we must complete the statement. Right, so they say CBA, like that. So you need to pair it up appropriately. So FGH is the answer. But we check and see what they want. It's an SSS similarity, and that's indeed right. Now, what about these triangles? Well, yes, they are by a 4:7 ratio, and thus the UT is similar to triangle VLM. But how do I know? Well, no, those two angles there are vertically opposite, and so it becomes a side angle side similarity. It's just a case of figuring out the scaling factor, isn't it? Here, I don't know that. No, I do know that they're similar. They're just not congruent. So triangle JKL is congruent to triangle TUV. I say. And they say it's the AA similarity. Interesting. Okay, that's what they say. Well, we know that these two angles match by being vertically opposite one another. But we actually know that the other two angles don't match. So no, they're not similar. Here, presume CM is 107. So 25 to 107, and then 16 to 72. That's not right. The relationship of 16 and 72 is are both in the 8 times tables. One is 2 times, one is 9 times. So in other words, I'd need to divide this by 2 and then multiply it by 9. And 12.5 multiplied by 9 is like 112.5, but they're not congruent, I believe. They're not similar. Similar is what we're focusing on right now. Okay. What about in this case? Well, here, notice all the multiples of 5. The third, the fifth, and the sixth. And here, notice all the multiples of 7. Actually, notice the multiples of 14. The third, the fifth, and the sixth. And so they are congruent. And what's the scaling factor? That should be known. All right. What was it again? Okay, so divide that by 5 and then multiply by 14. And thus we can pronounce that, there's 2 ways, but it's not ordered, so it's fine. Triangle TUV is congruent to triangle QRS. Not congruent, it's similar. Read it right. Triangle TUV is similar to triangle QRS. Not paying attention. Okay, fine. No, I don't know that these are similar to one another. They do have a common angle, of course, but nothing else is known. And we check, and that's correct, and that's good. Triangle HGF. Consider that. Well, yes. By angle. But we don't know the scaling factor, but that's fine. And so triangle HGF is congruent to triangle HTS. Here, well, they have the 76 degrees in common. Anyway, 9 to 21, is that 18 to 42? Well, yes. Scale by 2. And thus we say triangle FGH is congruent to triangle VUW. And check. And it's off the page. But it's fine. Is triangle FED congruent to this one? Let's see. 88, take 56, 32. 143, take 91, 52. Now think, 52 and 91, 13 times table. 13 times 4, 13 times 7. 8 times 4, 8 times 7. So, side angle side. In fact, we have 4 times 11. Wait. No. That's absolutely fine. 4 and 7, of course, make 11, so that's absolutely fine. So what is the scaling factor? Divide the former by 4 and then times it by 11. So And thus we say triangle FED is congruent to triangle FRS. Is similar. Read the symbol. Here, they are in that ratio. That's true. And so we say yes. SAS. And what's the scaling? One's 3 times bigger than the other. And triangle TUV is congruent to CDE, triangle CDE. Find the missing length. The triangles in each pair are similar. Very well. Oh, wait, we didn't check. Okay, that's all confirmed and that's all good. Okay, so 22. Okay, so 54. Okay, so it says 618. So that's triple that. But anyway, it partitions it into 3 to 1. So 3 to 1, that would be 9 to 3. So 9. And here they're the same as one another. And scaling factor is double, but I say it would be 11. Check. That's right. Solve for x. The triangles in each pair are similar. Okay. But they really, really, really don't look it. Okay. So, x would be 8. Not quite sure what's going on here. Surely divide by... No, I get it now. Okay, so x is 9. And that's correct, and that's good. No, wait, there's a better way, isn't there? What's going on here? Yes, divide by 3 to get 12. And then times that by 8. Okay. Sorry. So it's that many times bigger. And anyway, sort of a difficulty here. Not sure what it is. Yes, that's 3/8. I know that. So 24. So 7. And here. Okay. Okay, that's good. And now similar right triangles, huh? Oh. Hmm. Hmm. Mm-hmm. So what? I use Pythagorean theorem. So what? 8x is 8. Uh. Not sure, but I could use. Well, I know that that's 64, and that shorter side is 36. But it doesn't sort of like help me. 18 to 32, 9 to 16. I have a feeling that's 36, but I really can't quite tell. I guess I need to learn this. And I just never learned it. Okay, so it's 48, and I need to figure out why that actually is. Why is it 48? What's actually going on here? y. That's 3 to 4. Really? I guess this is one fact that I've never known before. Triangle IRE is similar to triangle ITR, which is similar to RTE. So all those triangles are similar, for sure. Okay. There's only 3 lengths that I know for sure. Guess I don't understand how this actually works then. Right, okay, this is genuinely interesting to me. So I'm going to take these 2 facts and I'm going to see if I can figure out how it works. And this is really good because I actually don't think in proportions, do I? Come on, try and figure out how it works just using simple-minded thinking. Okay, so let's just draw a picture here. Let's imagine this. And they're all similar. Okay, and the big guy, we know that that's 25. And we know that one of them, the smallest one, has 9 there. And we know because of that, there must be 16 there. And what we are to find is the hypotenuse in the smallest one. And we're told that it's 15. Likewise, over here. $100. 64. 36. And we're told the guy there is 48. And over here we're told okay, how does one do that though? One. How does one do that? Who's one? Okay, 3 to 4, 3 to 4. Nine to 16. It's just 3, 4, 5 triangle again. 3, 4, 5 triangle. And if it is the 3, 4, 5 triangle, then that makes sense. And if that's the 3, 4, 5 triangle, then that makes sense. Okay. Okay, carefully now. So x is 12. Okay, good. All right. Okay. A triangle has 5, 4 ratio. Root 41. What, like 81 over root 41 and then times that by 5? No, 27 root 5. Okay. I need to know what's actually really going on here. Okay. I better, I guess I better come back to this. This is very important. And I don't want to be too held up on this because I tend to leave routinary things to the night. But this is very, very, very important that I get this, whatever this is, because this is revealing the hole, the gap. This is the very thing that I was after. So I'm actually not going to save it because I don't yet understand it. And I'm going to be back to do algebra, which I know very well, which I know reasonably well. Be well.